Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we built the F statistic using the sum of squares. Now we'll see the second formula for the same F test, but we're going to use the R squared. So this is not a new test, it's just the same test written differently. The main idea why we can move from the first formula to the second formula lays in the fact that we have already established that the R squared as a formula itself was the explained sum of squares divided by the total sum of squares. So the R squared is just a rescaled version of explained variation. We also know another identity that the total sum of squares is equal to the explained sum of squares plus the residual sum of squares, which means that overall, if I am to rearrange this expression, then I can write the residual sum of squares divided by the total sum of squares as being equal to 1 minus the R squared. Simply, if I imagined dividing everything by total sum of squares here, this would be 1. Then this is my R squared. If I rearrange them, this is the new formula that I'm getting. So based on this new formula, this new representation that I'm seeing in here, the R squared tells us how much variation is explained, and then this 1 minus R squared tells how much is left unexplained. But keep in mind, both they are as fractions of the total variation. From the previous video, we also know that the F-test compares explained variation per regressor to unexplained variation per degree of freedom. So if we wanted to translate that using now this new relation that we just established in here, the formula for the F test will be R squared divided by K, the degrees of freedom, so the number of regressors that you have, 1 minus R squared divided by N minus K minus 1. And let's translate this slowly so that we can make the connection and the parallels of like, why is this the same information as what we had in the first formula? Well, as we can see here, we've got this R squared divided by K. That is your explained variation per regressor, since you're scaling it with the number of regressors. Then 1 minus R squared divided by N minus K minus 1. This is your unexplained variation per degree of freedom, because as you can see, you have divided that by the rest of the degrees of freedom. So as you can see, it's the same exact logic as the sum of squares formula, just expressed in percentages rather than in units. Why would this version of the F-test be more useful compared to the previous one? And the reason behind it is purely because of what kind of information we get in most softwares when we are under regression. The R squared is reported directly into the output. You don't need the full ANOVA table, so to speak. It makes model level testing a lot faster. So it's just a little bit for convenience, but it doesn't mean that you're running a different test. Now, the R squared base formula appears quite often in textbooks, in theory discussions, and especially when you compare nested models. Sometimes the software may hide it, like the results that you get out of specific software, but it's always there conceptually. Keep in mind, seeing the R square, like just because the R square is now part of the F-test formula, it does not mean that the F-test is just about the R square. The F-test still uses degrees of freedom, compares explained to unexplained variation, and tests joint hypothesis. So the elements for the F-test itself is not changed. It's just a messenger that gives that information that's changing from the ESS, TSS to the R squared instead. Okay? In the next videos, we'll see a little bit more of the proof because for some courses, you might have to show the algebra of how you get from one formula to the other. But keep in mind, this is also another way for you to remember that you yourself can get from one formula to the other without having to remember by heart two different formulas. So stay tuned because in the next video, we're going to show how to get to that proof all by yourself before we move on to actual examples with the joint hypothesis test using the F-test. Stay tuned and I'll see you in the next video.